We're live for the June 2026 Geometry Regents. And yeah, we're going to get started. But first, I do have to apologize for before. 100% my bad. I had a childcare thing pop up. It's just me taking care of my two kids. Me and my wife both work, and I had the wrong time in my head, and I was checking on the stream and I saw like, oh no, like the chat's going. So I truly apologize, especially the people who moved their plans around and lost time. So sorry to those people if you are here. So but we are going to go to a full Regents as I promised. So let's get to it. I went back in time, January 2016 but there's plenty of good questions on here. Not many of them I would say are outdated, so it's still good. I mean, geometry is thousands of years old, so if we go back 10 years, that's going to be quite all right. So yeah, I'm doing January 2016. And yeah, good luck. Yeah, everyone gets hundos, I hope. That would be magical if everyone got 100. But yeah, shout out to all the people here. And shout out to my actual kids that I teach in school, my period 8 geometry class. It was really nice working with all of you this year. And if you are here, I'm glad you're here for one more class before your Regents. So, all right. So let's get to it. So question 1, we're in the part 1, multiple choice. And we have, let's see, William is drawing pictures of cross sections. Okay, so cross sections I think of as this is like a slice. Okay, so if I had, let's say, something easier, like a cylinder. Okay, so here's the cylinder. Okay, so cylinder here. And I take a cross section, let's say this way. This would be one cross section that I could say is a circle. Okay, so I could say like, oh, this cross section, so the cross section here is a circle. Okay, so the cross section is a circle. Okay. So it's just me and my kids. So you'll hear my kids in the background for a little bit, but they will fall asleep probably soon. Okay. So all right. So here, the next type of cross section we could get is a rectangle. All right, so see here that we have a rectangle is another kind. So just think a cross section is a slice. So just keep that in mind. So for this question here, which cannot be a cross section? Well, the square, there's no way to get a square out of a cone here. Okay, no matter how you slice this thing, you're not going to get a square out of this. If you slice it horizontally, you get a circle. So that's why this shape here is out. All right, this is kind of circular looking. Triangle would be if you slice it straight down like this. So that's how you would get a triangle. So that's why 2 is out. This one doesn't seem like, how would I make this? That would be if you cut it at a slant. So if I chop it like kind of like on a diagonal here, like this, like coming down like this, then part of it would look, like that's where this wacky piece would come from as I'm chopping. So that's why this one's out and choice 1. All right, so this test, though, I'm going to say some questions are definitely a little bit rough. But yeah, last chance before tomorrow. I mean, I know I get a lot of comments like people are scared. It's normal. Like, uh-oh, will I pass? Like, what's going on? But, the best thing you could do is what you're doing right now. You're on a review, and I have Regents videos going back like plenty of years. I make these, like, I genuinely do like reading the comments when people are like, hey, like, I didn't know if I would make it. And then, I was studying, watching your videos, and I passed. Like, I love hearing that. So if this helps you through tomorrow, like, believe me, I wish everyone here would pass. But we're all going to get a different, experience tomorrow. And either way, you learn something. Okay, equation of a line perpendicular to the line represented by this equation here. So let's say, like, I'll show you how to do this the technical way, and then I'll show you, like, the emergency way. So for this, let's say I'll show you the math first. Slopes of perpendicular, you could abbreviate. So this means perpendicular. So slopes of perpendicular lines are opposite reciprocals. So remember that. Okay, opposite reciprocals. I had a professor from Sweden who used to say reciprocals. That's how I know how to spell reciprocals. So just in case you're like, oh no, how do I spell it? All right, so here, the slope of the starting line, remember from Algebra 1, y equals mx plus b. So the slope of the starting line is the coefficient of x, and the slope is negative half. Okay, so the perpendicular slope, though, we would take the opposite reciprocal. So I would flip this and change the sign to positive 2. So that's why like these answer choices are out. See how these are the only ones that are possible here because the slope there is 2. But the added condition is that the line has to pass through 6, negative 4. So then you could use y equals mx plus b. So I'll say over here, like option 1. This is for like the y equals mx plus b enthusiast. Like you plug in x, y, but you plug in the perpendicular slope. So you would do y equals, so you'd have negative 4 equals. Slope is 2 times x is 6, and then plus b. And you get negative 4 equals 2 times 6 is 12 plus b. And then subtract 12. And you would have negative 16 is equal to b. Okay? So that's why the y-intercept here, choice 4 would be it. Option 2 would be a little different. So option 2, maybe you like this formula more. They do like to use this formula on the regions. Y minus y1 equals m times x minus x1. And here I'd still use this, but now I'd call it x1, y1. And I'd have y minus negative 4 becomes y plus 4 equals 2 times x minus 6. And, oh, hang on one second. Sorry, yeah, they like want, my kids are going to sleep right now and their mom's not home, so they're like, you know, not super thrilled about it, but hey, that's parent life. Okay, so 2x minus 12, and then I subtract 4 on both sides, and I get y equals 2x minus 16. Okay, so that's, option 2. Option 3, so you ready? So option 3 would be calculator. You're like, oh no, I don't know what's going on. Like, this is tough. So then what you do is you could graph the question. So negative half x. So negative half x. And then minus 5. You know what? I'm sorry, people. I'm going to do a quick ad break because I got to talk to my kid real quick. So I'm going to press the ad button. I'll be back. Let me see. Is there an ad button here or something? So, because he just needs some, like, reassurance. Like, hey. Okay, here we go. Ad time. All right, I am back. So sorry about that. I had to say goodnight to my kids again, but hopefully that's it. Alrighty, so y equals negative half x minus 5, and then we've got all the answer choices. So if I write in like 2x minus 16, this is where the TI is not perfect. For the schools that have Desmos, like we're all jealous, but see how like these lines intersect? That doesn't look 90 degrees, but I promise it is. Because the negative half x ones would be parallel, not perpendicular. And then I press second graph and look here at 6. See how we get negative 4. So it passes through 6, negative 4 like it's supposed to. If I did the wrong answer, 2x plus 14, it would miss 6, negative 4. So I'm just pointing that out. All right, cool. So that is option 3 is to graph. Alrighty, moving on to question 3. So question 3. All right, these kind of questions here, I call them like just do them by brute force. Just like hopefully you show up knowing like all the properties that you need. And yeah, so just pointing that out. Let's see. Label first. So parallelogram, blah, blah, blah. Diagonal, TR. Okay. And what do they say? TS, blah, blah, blah. All right, so they're just saying like, hey, we have a parallelogram, so that's important. And then they tell you S, measure of angle S is 60 degrees. Okay, so here we go. Now we have useful stuff. So if this is 60 degrees, Q is 60 degrees, Because remember, opposite angles are congruent. And this is for parallelograms. This is not for any quadrilateral. This is only for, this is unique to parallelograms. Opposite angles are equal. They told us also here, SRT is 83 degrees. Okay, so SRT is 83 degrees. Another big idea is, so this one we're going to use, consecutive angles are supplementary. Okay, consecutive angles are supplementary, which means they make 180. So where my head goes, I say, okay, 180 minus 60 is 120. So that means this angle plus this angle, like this one over here, these two have to make 120. So then what I would do is okay, 120 minus 83. And if you subtract those, you get 37. So that tells you this one here has to be 37. So like brute force means just use all the properties you know and find all the missing angles and hope for the best. Then they tell us TWU is 35 degrees. That's this angle over here. All right, so now we're getting somewhere because the goal is to find the measure of WVQ. Let's see, WVQ is over here. All right, I see it. So maybe you see it also. This angle over here is 35, so vertical angles are equal. So this is 35. And if this is 35 and this is 37, exterior angles theorem. You ready? So if I have, let me make that more, easy to read. So if I have this is X and this is Y, the exterior angle is X plus Y. So this angle out here, I would just do 37 plus 35 is 72. So this angle out here is 72 degrees, and that's going to be choice 3. Okay, so choice 3 it is. All right, so moving on, question 4. Let me just double check. Yeah, that one's choice 3. Okay, question 4, we have a fish tank. Oh, rectangular prism. Okay, dimensions are 14 by 16 by 10 inches. And the tank contains 1,680 cubic inches of water. What percent of the fish tank? Oh, all right, I see what's going on here. So here's our, here's a fish tank. Okay, so fish tank over here. Not my best, well, okay drawing here. Okay, so rectangular prism. I'll just move this over. Whoops, wrong button here. Let's try that again. Okay. So we have this, and actually that's enough. We could see that. Okay, so this is 10 inches by 16 inches by 14 inches. Let me write it in order, actually. It doesn't matter where I write it. Like it's, because the volume we're just going to be multiplying anyway. All right, but just so you can kind of see what's happening. So 10 inches. However, if I find the full volume here, 14 inches times 16 inches times 10 inches. So I work this out, and let me just go ahead and do that. Okay, so let's see. So we multiply 14 times 16 times 10, and we get 2240. Okay, so the volume is 2240 cubic inches. All right, but that's the full tank. They're like, if you think about it logically, a fish tank, they're not going to fill it to the top. They're going to fill it like partially. And they're saying, hey, we're only filling it like up to 1680. So 1680 is the part that's filled out of the whole tank is 2240. So just remember, when they say like what percent, just think part over whole. Okay, so part over whole. And now you just work this out. But be very careful here. So let's see like a potential tragedy here. So a lot of, ready for the first bear trap. Yeah, this was like a very bear trappy Regents, I think. Let's see. 1680 divided by 2240 is 0.75. So we get this and we're like, all right, so like it's 75% full. And then like this is like LOL, like bear trap. Don't choose that. They're asking you what percent of the fish tank is empty. So what percent empty, not full. So then if 75% full, then 25% empty. All right, that's kind of mean that they do that. Like you do all this amazing work and like, haha, we said empty. It's like, all right, you got me. Yeah, I'm going to do proofs. If you like scroll through the Regents at the end, The proof at the end is like pretty awful, but it's good. I think it's good to see. And yeah, they're like, this is a hard Regents. January, I feel like they, as a joke, make it harder because they're like, oh, you failed the Regents? Don't worry, you can retake it. And they just make it like scorched earth level difficult. All right. Oh, do I know the leg rule? Yeah, I mean, definitely no leg rule. So for sure do that. But yeah, so leg rule is like important. All right, don't skip leg day. All right, all right, here we go. So which transformation would result in the perimeter of a triangle being different? All right, so transformation that makes the shape different size, dilation all the way. Like dilation changes the size of the shape. Changes the size of the shape, but it keeps the angles the same. But keeps the angles. So like imagine like this triangle here. All right, so I group this and then duplicate. So like if I want to dilate this, like it's like still recognizable. Like, oh, hey, I recognize that triangle. It's just like a scaled up version of it. So the one that does it is definitely choice 3 because you see they're multiplying the x and y term by 4. So that would like make it in a way like quadruple. Yeah, triple, quadruple, quintuple. I don't know. I'm like a little rusty on that stuff. But let's see. Like if I make this point here, dilation, it's like I'm taking the distance here from here to here. And I'm like, let's see, 1, 2, 3, 4. Yeah, like quadrupling it. So if I do that like all across, like it's going to make this cool shape over here. All right. So that's the idea. It would be this one. This would be reflection. So reflection over y equals x, I want to say. So if you reflect over the line y equals x, that would, if I had like the point, let's say 2, 1, that would go to the point 1, 2. Like, so 2, 1 would go to like 1, 2. So you just switch the x and y. This is reflection over the x-axis. So I have to like close my eyes to like see it. Because I can't memorize rules, but I just draw them out. I'm like, all right, if I had the point 2, 1, and then I just change the y negative, it's reflecting over the x. But reflection is remember this phrase for tomorrow, rigid motion, big vocab term. Rigid motions, preserve, let me make that neater. That's like my worst lowercase m I've written in a while. So rigid motions preserve distance and angle measure. Distance and angle measure. Okay, so just make sure you say, when they say like, hey, using proper, like explain why these triangles are congruent with this sequence of transformations, say that sentence. Rigid motions preserve distance and angle measure. Therefore, the shapes are congruent. Like they love hearing that when they grade because it's so familiar. Yeah. Oh yeah. New. I want current stuff. I have all the new regions. So just like watch the video. It's just I won't be able to like make cool commentary. All right. It's already recorded, edited, all that stuff. All right. So what's going on here? This next one. So now we're on question 6. Which statement? Oh, these. All right. So these are like kind of awful. Just like do your best to read what they tell you. FE bisects AC at B. All right. So this, sometimes you got to reread it multiple times. FE. So that's like this one over here. FE is bisecting AC. That means I can say these two are equal. All right. So that blue stuff allows me to make these marks. Then they tell you GE bisects BD at C. So now GE is cutting BD in half. But I could put a single tick mark here because if BD is being cut in half, that means like this half is equal to this half. So that means all three are equal. So which statement is always true? Well, now let's see. AB is congruent to DC would always be true. Okay, that would mean this one has to be congruent to this one. All right, FB is not equal to EB. We can't say that because they didn't say, if they said, let's see, FE. Actually, no, not even because FE is a line. So you ready for this? FE is a line. So we can't even say bisect each other because these are not line segments. These are lines coming through. So you can't really bisect a line. You can only bisect a line segment. So you see this is like line segment with just the like without the arrows. And this is line. and this is line segment. All right, so this is a nice little vocab heavy question. Okay, but 6 is choice 1. Oh, I'm glad it's easier. Yay. Okay, cool. All right, so as shown in the diagram below, a regular pyramid has a square base whose side measures... Oh, let me get the new reference sheet, because the new reference sheet is like total garbage. I don't know, New York State, I don't know, like, they're just like angry at teenagers. They just want to like make you all suffer. But it's like a pretty whack reference sheet. It's got like... What does it have? This is your reference sheet. But actually here it would be a little bit useful. So this is what you'll get tomorrow. Okay, you get this. Okay, so there's your wonderful reference sheet. It's got like 3 formulas on it, which is nice. And nothing else. The rest is in your brain, or you could just figure it out, hopefully. But this is all you get. So pyramid is this one. Volume equals 1/3 capital B times H. Capital B is the area of the base. But since you have a square base, you just have to think like, all right, square base. Just think of a square. But this square is 6 by 6 inches. So if you had to find the area, you do 6 times 6 is 36, but square inches. So like inches times inches is inches squared. So this is like my capital B. All right, so I say, all right, volume equals 1/3. Capital B is 36 square inches times the height. And they told us, oh, the altitude, that's a fancy word for height. All right, this is also known as the height. So that's like they're being like, you know, sneaky here. I don't know if you ever flown in a plane, like they say like, oh, we're now flying at an altitude of 20,000. Like that's how high up you are. So your height. Okay, so the altitude is 12 inches. So times 12 inches. And now just multiply this out. If you want to like, you know, do some mental math, that's cool. If I was doing this math in my head, I would do 1/3 times 12 first is 4. And then 4 times 36. The math I do in my head, I just do 36 times 2 times 2. I just double it twice. So I get 72 times 2 is 144. So this works out to this. So 144. Now, I'm going to point out something else. Inches squared times inches is inches to the 3rd power, but we could say cubic inches. That's why cubic inches is inches to the 3rd. But I'm going to say you do not have to write units in the free response. Okay, you do not have to write units. So here's the rule with that. You don't have to write units, but then when you take physics, units matter a lot. All right, you'll probably have a physics teacher like scream at you if you forget to write units. So like don't be bad at units. But on the geometry regents, it doesn't matter. But if you like, hey, I still want to write units because I want the concept. Well, what could go wrong is you write the wrong units, you lose points. But if you don't write units, then yeah, that's what's it called? If you don't write the units, then like no harm, no foul. Okay, so yeah, just pointing that out. Cool. So all right, moving on. Oh, altitude and leg rule. Could I remind? So let's see. If we look here, altitude rule. Let me flip through here though and see. Do I have an altitude rule question? Let me just see. Question 22, there's an altitude rule question. So I'll hold off on that. When I get there, I'll write the leg rule too. All right. So moving on. Question 8. So question 8, we have, let's see. Triangle, blah, 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 blah. Oh, all right, here we go. Which sequence of transformations maps triangle ABC onto triangle DEF? So for this one, you just go through them one by one. Now, the danger here is check more than one point, because sometimes like it'll work for one, but it won't work for all of them. So reflect over the x-axis. So if we reflect over the x-axis, I would just count the boxes. So let's see here. If I go over the x, I'm going 1, 2, 3, 4, 5, 6. And then I'm going 1, 2, 3, 4, 5, 6. And then reflect over the y-axis, which puts us over here on point C. And let's see. We're trying to send, ABC onto DEF. Oh, well, if I go this way first, if I go backwards, so let's say I reflect over the x-axis first, but I start from point C, it's still going to bring me like up here. And then I go over the y-axis, it puts me over here. So C and F have to map to each other because they're in the same corresponding order. See how they're the last, They are in the last spot. So that would tell us then that B would have to map to E. So if I go to B and I go over the x-axis first, that's 1, 2, 3, and then 1, 2, 3. And then reflect over the y-axis, I would go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So B is mapping to E. And if I do this for A, that should go to D. So I go up 1, 2, and then 1, 2. And then I go 1, 2, 1, 2. So the first one is already it. All right, this one works. But now, why are the other answer choices wrong? So if we 180 rotate about the origin, that would work. A 180 degree rotation about the origin would send the points to where they need to go. However, they're not just rotating about the origin, they're reflecting over the line y equals x. Which if I go over the line y equals x, see, that would send this point over here. This point would go like somewhere over here. So this wouldn't work. Okay, this would send it, all out of whack. A 180 rotation, though, would do it. But they added something extra, so no. All right, so that one is out. And then, let's see. A 90-degree clockwise rotation about the origin, followed by a reflection over the y-axis. So why is this one no good? 90-degree clockwise rotation. So what I like to do when I'm rotating, I'll show you a little trick I use, is when I rotate something, I actually take my paper and I turn it. So if I'm rotating 90 degrees clockwise is like going this way. So that would be clockwise. I would take my paper. So I take your test paper and actually like turn it and stuff. So I would turn it like this. So ABC, I would say, all right, if I go 90 degrees clockwise, so let me just make sure this is nice. 90 degrees clockwise would send, let me get rid of this stuff. So ABC, like A would go to this point. C would go to, let's see, it's at -1, like -6. So go to -6, 1, 2, 3, 4, 5, 6, and then over here. So go like this. And then B looks like it would go to, let's see, 1, 2, 3, and then 1, 2, 3, 4, 5, 6. So -3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6. So it would send us here. But then if we reflect over the y-axis, see how it would miss? It would go 1, 2, 3, 1, 2, 3. It wouldn't land. Okay, so that's how I would handle that one. And I'll leave this one open as an exercise just for the sake of time. Also fails. All right. All right, I'm just trying to follow the chat here. Okay. All right, so just... Oh, if they ask you to write it... All right, if they ask you to write units, then you write the units, but they almost never... I've never seen them say that at the Regents. They'll just say, like, how many grams to the nearest tenth of a gram, and if you just write the number, you get the credit. Yes, you don't have to use units, and you still get full credit. All right, I'll even look that up right now to be safe. Can you leave units out on the New York Geometry Regents and get full credit? Yes. Okay. No units are required for the answer. All right. And this is in the rubrics too. So units do not need to be included for the Geometry Regents. Unless for some reason they word it and they're like, hey, write the units there. But I have not seen that. Okay. So I'm just, pointing that one out. All right. So now moving on. Oh, all right. So this sneaky theorem. So this one here. And this one, if you forget, you could always come up with something. Like just plug in numbers. So if A plus B equals 90. That's what it means. Like the complement of B is A. So that means A plus B is 90. Okay. And A and B are acute. So angle A and angle B are acute. Okay. Then we could say sine of A equals cosine of B. All right. If you're like, whoa, that doesn't make any sense. Well, I'll show you like how to investigate. If you ever forget a rule, remember, you could just kind of plug in numbers and hope for the best. So they're saying the complement of B is A. Complement means makes 90 together. So if I did like sine of 70, and then I did cosine of the complement of 70 would be 20, because 70 plus 20 makes 90. See how I get the same ratio? All right, so sine of an angle is equal to cosine of the complement. If I did sine of, let's say, 55, the complement of 55 would be 35. And see how I get the same thing? Okay, so that's how we would handle that. So sine A is equal to cosine of B, choice 4. All right, question 10. So question 10 here, we would have a line that passes through the points whose coordinates are 1, 1, and 5, 7 is dilated by a scale factor of 3, centered at the origin. Okay, the image of the line. Oh, so this is just a concept. So if I had here, so the center is 0, 0. So 0, 0, and then 1, 1 is over here, but 5, 7. So that's, let's see, 1, 2, 3, 4, 5. Oh, so I had to say it, 6, 7. All right, so here, and then this is going higher. So 5, let me just drag this down. Okay, I'll draw this a little higher. So over here, so we go over, once again, over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7, like this. This line actually would not pass through the origin if it was like, how do I say this best? You know what? Yeah, the line, so that this doesn't get too complicated, the line that connects 5, 7 and 1, 1 is not going to pass through 0, 0. Now, how I know that, if it was like 1, 1 and 5, 5, then yes, this would be on the line y equals x. And if it's on the line y equals x, then 0, 0 would be on that line. But because it's not 5, 5, it's 5, 7, that wouldn't happen. If you really want to, let's say you don't like writing the equation of lines, well, you could use the calculator to get the equation of the line here. So remember, I don't know if you remember this from Algebra 1. Stats, edit, but the point 1, 1 could go here. And let's say you don't know how to write the equation of a line, but you really want to get this right. And then 5, 7, you could write next to it. And then do stats, calculate linear regression. And this will write the equation of the line for you going through 2 points. So it'll be the line y equals 1.5x minus 0.5. So 1.5x minus 0.5. Okay, and then here, if I graph this, see how it doesn't go through 0, 0 if I press second graph? When x is 0, y is not 0. All right, that's very important because if you do a line dilation, so a line dilation like this, and the line is not passing through the center, your new line is going to be different. So if I scale it out like this, the new line, see the distance from here to here gets multiplied by 3, so it would go somewhere over here. So the new line would actually be parallel to the old one. Okay, so it would be parallel to the original line. Okay, just remember this phrase, dilated lines are parallel. Except in one case, okay? This is the sneak attack. So you ready? The sneak attack, bear trap of the century from the Regents is if they give you a line like this and the center is on the line. Okay, so if your center is on the line, then when you dilate all the points, like let's say you triple the distance and you go out, they're still going to be on the same line. Okay, then it would be is the original line. So this is like the center is on the original line. Okay, but that's not what happened here. So parallel. All right, yeah, 2016, but I think you could all see here, like this is like very current stuff, like the dilated lines being parallel. If the center is on the line, then like that's no good. So yeah. Alrighty, so here quadrilateral ABCD is graphed on the set of axes below when rotated 90 degrees in a counterclockwise direction. Blah, 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 blah. Okay, let's see. Is distance preserved under the... Yes. So rotations are rigid motions. Remember that. Okay, rotations are rigid motions. Okay, if I, like myself, I'm sitting in a chair that could rotate. Like if I rotate like this and I move, like I didn't change. I'm still the same, person doing this live stream. So rotating in your chair doesn't make you taller or shorter. So you can rotate all you want, but just don't get dizzy. So just remember that. And so it's not going to be no. And let's see which point they're talking about because I lost track here. When blah, blah, blah. And which coordinates are correct? Oh, all right. So here, this is that little trick I was trying to show everyone. When you forget the rules for rotation, because I can't remember how to, I can't memorize the rules for rotation. I just take the page and I turn it. So if this is rotated 90 degrees counterclockwise, would mean turn it like this. So we turn our page and then we look for the answer. Okay, so let's see. A prime is at 6,2. That does not look like A prime. 6,2 would be over here, and nothing is over there. B prime is at negative 3,4. That has to be it. Let's see. 1, 2, 3, and then up 1, 2, 3, 4. So that's where B prime is going to be at negative 3, 4. You just, once again, take your page and you rotate it, and then you don't have to memorize the rules. Okay? All right. So choice 4. Let's see. We are just check. 36 minutes in. All right, we're making decent progress. All right, so this one, diagram below of circle O. The area of the shaded sector is 2 pi square centimeters. Okay, so this is the area of the sector. If the length of NL, so this is the diameter. So this is the diameter because it's going, well, they said, they're showing here ln is going through the center. So this is the diameter, which means the radius is 3 centimeters. That's going to matter. What is the measure of angle N? Oh, this is a good question. Definitely a hard question. So remember, the area of a sector, I'll just say the area of a sector like this, is pi r squared, which is this is the area of the whole circle. So this is the area of the whole circle, and then we just multiply it by whatever this angle is, theta, over 360 degrees. And this is the central angle. Okay, so now I just start solving for this stuff. I say, all right, here they told us that the area of the sector was 2 pi. So I could say 2 pi equals pi times the radius is 3 centimeters, but I'll just say 3 squared, times angle over 360. I'll write units at the end. So now I just do the algebra here. If I divide both sides by pi, things will cancel. But let me think about how to do this nicer to make it more polite for... No, I'll show more steps. I don't want to skip too much algebra because then I think that'll make people upset. So 2 pi equals 3 times 3 is 9, and 9 times pi is going to give us 9 pi. And then we have times theta over 360. Like this. Okay, so first I could divide both sides by, let's see, 9 over 3. I could reduce first. I'm thinking in my head like, 9 over 360 is equal to 1 over 40. And if you're like, wait, how'd you do that? You could always use a calculator for this. So if I did 9 over 360 and I press math, enter, I get 1 over 40. Okay, so that's where that came from. So I could rewrite this now as, let's see, I'll write it over here. 2 pi equals, and now I could say pi over 40 and then times theta. And then multiply both sides by the reciprocal. So I could say times 40 over pi. Times 40 over pi. These cancel. And this allows me to say theta equals, so theta equals, pi over pi cancels, and 40 times 2 is 80. So this angle here is 80 degrees. All right, so 80 degrees. And then if this is 80, then this one over here is 80. Remember, central angles are equal to the arcs they intercept. But this one here is inscribed. So what is the measure of angle N is half of this. It's going to be 40. Okay, so 12, you're going to get choice 3. All right, a few other things work here. When in doubt, pick C. You could do that. This, you could just think like, oh, this is like almost 90 degrees. So like, oh, that's got to be 80. And then this is half of that. Like, that's a little like, I don't know. They don't say, oh, but not drawn to scale. This is like emergency. Like, oh no, this theory was too crazy. Then just do that. Or get out a protractor. Just measure it. That works too. And pick the one that's closest. All right. In the diagram below, these triangles are similar. This means similar. And let's see. AB is 6. This is 8. Which statement will justify similarity by side angle side? Okay. So side angle side similarity means like this one and this one. Like these have to be like scaled. And then these two have to be scaled. So like this and then the angle between them has to be congruent. Like angle A has to be congruent to angle D. All right. If you use angle A as congruent to, I'm sorry, let's say you did C as congruent to F. C congruent to F would actually be like ASS. It's such a bad word, I can't say it, so I'll just write it out. But there's no ASS similarity. Okay, so ASS similarity theorem is not a thing. All right, please don't write S on your regents. Okay, that would be bad. Okay, so don't write it. Okay, so moving on. Not a theorem. This is not a theorem. Please don't say, oh, Vin teaches math taught me that. I didn't teach you that. Okay, so here now you have to see which ones are actually like scaled up. So, all right, I see it. It's got to be choice 1. The way I do this math in my head, I'm like, all right, 6 over 8 is equal to 3/4. Like if I do this one over this one, it has to make 3/4. So 9 and 12 would work because 9 over 12 is also 3/4. 8 and 10 wouldn't work because if I did 8 over 10, that would make 4/5, which is not an equal ratio to 3/4. Okay? So yeah. All right. So moving on, let's see. The diameter of a basketball is approximately 9.5 inches. And the diameter of it, blah, blah, blah. Oh, all right. So this one, find the volume of both. Volume of a sphere. This is on our reference sheet. Is 4/3 pi r cubed. But they gave us the diameter. So diameter of the basketball is this. And diameter of the tennis ball is this. So what you want to do is say like, all right, like the first radius is 9.5 divided by 2. And 9.5 divided by 2 is 4.75. And then the second radius is going to be 2.5 divided by 2, which is 1.25. So you really just have to, if you want to see how many times greater, you just divide the bigger ball, the basketball, by the tennis ball. So ready? So the basketball volume is going to be 4/3. So let me do the basketball in purple. So it would be 4/3 pi and then 4.75 cubed. And then divided by the next one would be 4/3 pi times 1.25 cubed. Like this. All right, so for this one, now we just work this out. So let me get the calculator. So here I'm going to press. Oh, to make a fraction, please do this on the Regents. Alpha y equals enter. If you have the TI-84 plus, like the Python one, you press alpha x. But alpha y equals enter is very useful. So please know it. All right, 4/3. I could write without parentheses, or I could say 4/3 like this in parentheses. Then pi is second, and then this up button here. And then 4.75 to the power 3. And we're dividing that by 4/3 times pi times this time 1.25 to the power 3. And we get almost 55, but they said to the nearest, about how many times greater. So about 55. Okay, so this makes about 55. So let me just get this so it's like in the picture. So yeah, like a question like this is definitely fair game. Like every question we've seen so far, even though this Regents is like, 10 years old, is fair game. So 55 would be the closest. All right. So let's see. Question. All right, here we go. So the endpoints of one side of a regular pentagon are -1, 4 and 2, 3. What is the perimeter of the pentagon? So for one, you could know this formula for tomorrow, the distance formula. So you could have this memorized, which is, good to have. Or what you could do is, let me just do a hyper scroll to the end. You go to the last page, the scrap paper, and you borrow this. So let me just see. I'll just do cut. So cut, and there's, I think, another question here with, I'll paste it here. Can I just paste it? Oh, I can paste it repeatedly. So, all right, so here it's useful. And the other one. Okay, so let's say you don't know the distance formula. Or you forget it. You're like, oh no, I forgot the distance formula. Okay, so what you do instead is you would draw this out. So you go like this. And like this. And you say, all right, -1, 4 is over 1, up 1, 2, 3. I can't count. 1, 2, 3, 4. And then 2, 3 is over 2, and then up 1, 2, 3. And if this represents one side, you count the rise over run. So first I'll just say, all right, distance equals square root of, this is x1, y1, and this is x2, y2. And you just plug into the formula. You would do 2 minus -1 squared plus 3 minus 4 squared. And then distance equals, and I get 9 plus 1 here. So the distance equals square root of 10. Okay, now this is like 15, like LOL if you choose choice 1. Because they're asking you for the perimeter. A pentagon has 5 sides. And it's regular. And regular means all sides are equal. Okay, so I would just say, all right, like, so 5 perimeter equals 5 square root of 10. So choice 2. All right, choice 2 is the answer. For this, you could also go down 1 over 1, 2, 3. So if I make a right triangle, see I'm going down 1 over 3. If I make a right triangle, that's 1 by 3. I could use Pythagorean theorem to find the missing side. Like if I put a, let's say the letter C here, I could say 1 squared plus 3 squared equals C squared, which would give me 1 plus 9 is 10. And then I take the square root of both sides to get rid of the square. And the missing side would be square root 10. So I still get square root 10 as the distance. So, all right. Moving on. Oh, this is a classic question. So finding the missing angle using trig. So we want to find the measure of angle A. So angle A, this side here, always look for the right angle. That tells you where the hypotenuse is. So the hypotenuse is 14. And then this side here is next to angle A. So this side is adjacent to angle A, the 9. And then hear this phrase in your head. So remember SOHCAHTOA. All right, SOHCAHTOA. And you're like, all right, I have the adjacent and the hypotenuse, which tells me cosine. But what I would say is, all right, cosine of angle A, capital A, is equal to the ratio of the adjacent side over the hypotenuse. So equals 9 over 14. Okay, cosine of any angle theta is the ratio of the adjacent to the hypotenuse. So I set up the ratio 9 over 14. But then the opposite of cosine is cosine inverse. So I say measure of angle A is cosine inverse of 9 over 14. and then just type it in. Okay. All right, so moving on. So cosine inverse of 9 over 14 is about 50 degrees. Okay, so we're going to say 50 degrees. Now, one thing, if you're like really confused here, so let me just drag this down. So let's say I did sine of 30 degrees is a half. So when I do sine, cosine, tangent, you do angles. So sine of an angle gives me a ratio. But when I do the opposite, sine inverse of the ratio 1/2 or 0.5, it brings me back to the angle 30. So the inverse trig functions tell you the angles. Sine, cosine, and tangent, though, you feed them an angle and they give you the ratio. So they're opposites. All right, so it's very important. Like, because a lot of students will mix up. They're like, I don't know the difference between the two. And it's like they don't really understand what they mean. So sine, cosine, tangent, you feed them angles and they give you a ratio. And then the other ones tell you the angle. All right. So choice 3. All righty, let's see. Move in. You know what? Let me move this one down for when we do this one in a few. Okay. Oh, completing the square. So this one, I make space first. X squared plus 6 times x, space, and then plus the y stuff is y squared minus 4y. Leave a space. And then equals 23. So when you complete the square, you want to take the b term. So here are the b terms. Like we have 1 over here is 6, and the other one is negative 4. But you take the b term, you divide it by 2 and square it. 6 divided by 2 is 3, and then 3 squared is 9. So I get plus 9. Okay, and then I'm going to do 9 on this side too. Whatever you do to the left side, you have to do to the right. Golden rule of algebra. All right, so then next I'm going to go negative 4 over 2 squared. Negative 2 squared is 4. And that's the mystery value I'm adding to both sides to complete the square. So what will happen now is this will factor nicely. The blue stuff factors to x plus 3 times x plus 3. Because 3 plus 3 is 6. 3 times 3 is 9. However, I could say x plus 3 times x plus 3 is x plus 3 squared. And then I get plus, to factor this one, I get y minus 2 times y minus 2, because negative 2 plus negative 2 is negative 4, and the product of those make positive 4. But I could just call that y minus 2 squared because they're matching factors. Equals 23 plus 9 plus 4 is 36. And then we have to know this formula. When you have a circle with center h comma k and radius r, you could say x minus h squared plus y minus k squared equals r squared. All right, this formula you have to know. So if we look here, do you see the h value? So it's h and then minus h here. So it's opposite here. So instead of plus 3, I'm going to have minus 3 as my x value. Instead of minus 2, I'm going to go to plus 2. So that's why one of these. And then be careful. In the equation part, the radius is being squared. So r squared equals 36. And if I take the square root of both sides, that tells us the radius is 6. So choice 4, not choice 3. All right, great. What formulas do you need to know for the regents? That is a good question. Just everything. You know what? Let me see if I can find a complete list. What formulas do students need to know for the geometry regents? Memorized. All right, let's see. Distance formula. So you got to know the distance formula, midpoint formula, slope formula. Is the slope formula? Oh, they don't tell you that anymore. Of course not. So distance, midpoint, slope, equation of a line. You know what? Let me get a, how about this? I use like the Google AI to make this list. So that's good use of AI. All right, or at least maybe I'm like just trying to make peace with that. So this. Okay, so this. So you need to know this. all polygons and all right, these are important too. So these. So you want to, yeah, these formulas are important. There's also like, there's probably other ones. I'm going to ask like, hey, what about, what's missing here? Oh yeah, like leg rule and altitude rule. They'll be like, oh yeah, you're absolutely right. I love when AI is wrong. They're like, you're absolutely right. Like that's their, yeah, so I'll go over altitude, leg rule, and all that later. There's still some other formulas that I'll put down, but these are good to know. So like, definitely know these. How about we'll just throw that line in there. Know those formulas at the very least, and then some. So that's a good start. All right. So here we have these points. So let's see, -2, -3, and then 8, 2. And these are the vertices. Oh, I mean this, all right. If you bring a straight edge to the Regents and you just draw as neatly as possible, like this could really help. So -2, -3. 8, 2 is 1, 2, 3, 4, 5, 6, 7, 8. And then up 1, 2. And then T is at 1, 2, 3, 4. Up 1, 2, 3, 4, 5. So this one is looking like a right triangle. All right, it looks like we have a right angle at point T. Now, if I had to prove this, because I'm like, all right, it looks right, but like maybe not. Maybe it's obtuse. Maybe it's 91 degrees. So like, like how do I prove it? I could prove it either with Pythagorean theorem or slope. So let's say I go slope. If I want to find the slope of, let's say, RT. So the slope of RT, I could just use the slope formula. Remember, y2 minus y1 over x2 minus x1. So the slope of RT, so I'm doing this one and this one. I take the difference of the y values, 5 minus -3, and I divide by the difference of the x values, 4 minus -2. So I get 8 over 6, which is 4/3. Okay, and then I find the slope of TS. So the slope of TS, now I'm doing this one and this one. So I get 5 minus 2 is the difference of the y values divided by the difference of the x values. And this gives me 3 over -4, which is -3/4. And check it out, these are opposite reciprocals. Okay, which I spelled before, which means, so therefore, RT is perpendicular to TS, which then tells us angle T is a right angle, which means this is a right triangle. Okay, you could do that, or you could use the distance formula to find the length of all three sides and show they satisfy Pythagorean theorem. Okay, so I already did distance formula before, but I promise you this is square root of 125. TS is equal to 5, and RT works out to 10. You just use the distance formula 3 times. And if I plug into Pythagorean theorem, 10 squared plus 5 squared equals the third side squared, gives me 100 plus 25 equals 125, which is a true statement. So this is a right triangle. So that's another way to determine this is right. Cool. All right, moving on here. Let me check the... let me just see the chat. Oh, I didn't say this yet. Oh, for one, thank you for the tip. Help with rigid motions. I'll definitely come across another. Let me see. Where's rigid motions? It's coming up. Yeah. So I can mention rigid motions again on question 25, and also, question 28 is like rigid motions. Like it's all about rigid motions. So just stay tuned until question 28 for sure. Thank you to everyone that's here. I haven't said this yet, but if you have not subscribed yet, please consider subscribing if this is helping, because it does help me grow the channel. I have a near goal of trying to get to 50,000 subscribers, which would be so cool. All right, I'm like 205 away from 50,000, which is exciting stuff. I also started posting shorts on TikTok as well, but yeah, YouTube is like my home base. But TikTok is like very exciting. That seems to be like where all the high schoolers are going these days. So I'm trying to like, listen to the crowd as well. But thank you for coming here. Thank you for the support. Yeah, I hope you all do well tomorrow. Oh, what's the 3, 4, 5 triangle that you use for? So 3, 4, 5 is like a little SAT shortcut. So on the SAT, these are called Pythagorean triples. Like these make right triangles. 3, 4, 5. There's 5, 12, 13. There's this one, 8, 15, 17. And then there's this one, 7, 24, 25. Those are like the popular, they're called Pythagorean triples. Like what we could just like, oh, I know these make right triangles. But if I had like a scale factor of, let's say 3, then this would make 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So I could find missing sides of right triangles without using Pythagorean theorem if I have these basic Pythagorean triples memorized and I recognize them. Okay? So just, yeah, pointing that out. Cool. So now we, gonna move on here. All right. So, let's see. Sorry, I lost my train of thought for a second. Oh, yeah, math. You teach math. Okay. All right. Molly wishes to make a lawn ornament in the form of a sphere, the clay being used. Oh, so density. So density equals mass over volume, which tells us if we cross multiply, the mass of an object is equal to the density times volume. So just, this is a good one to know. Spheres, yet again. So the clay being used weighs 0.75 pounds per cubic inch. So this is the density. They're giving us, like this one here in green is the density. And we have the radius. So volume of a sphere, remember, is 4/3 pi r cubed. So this is for a sphere. Okay, and then, so if I do 4/3 pi times 4 inches to the third power, I like to write the units just so you can see what's going on. So this, if I work this out, so let's see. So we got 4/3 pi, and then r is being raised to the third power. So that's the volume here, unrounded. But then the density is 0.75 pounds per cubic inch. So I'm just going to multiply by 0.075. And it looks like 20. Choice 2 is going to be our answer. But I'll show a little bit more like why, because that might be a little confusing. Okay, so this. Okay, so we have this, and if I work this part out, this was the volume of the sphere, was 268.08257, and it was inches to the third power, which is cubic inches. But if I want to find the mass, 268.08257 cubic inches times the density was 0.075, and it's pounds per cubic inch, which is inches to the third power. Think back to Algebra 1. Like these units here cancel out, and they give you just pounds. So that's why our answer here is the units that we need, like your mass in kilograms. But in physics, like it's also due to gravity. Like on Earth, gravity is like 9.81 meters per second squared. But on different planets, like somewhere like, I think Jupiter, I'm going to stay in my lane, but leave it for a second. That on a planet like Jupiter that's like more massive, you'd actually weigh more because gravity's stronger. All right, like in theory, if you were able to like handle that kind of, pressure. All right, so that's that. So let's see. So the ratio of similarity of triangle boy to triangle girl is 1:2. So I would draw this out. So triangle BOY, and then triangle GRL. Make sure the letters are in corresponding order. Like if I'm going B first, then G has to go first. If I go O second, then R has to be in the same place. And if I write Y last, then L has to go where Y is. All right, so that's very important, so that you set this up right, because correspondence matters big time. So x plus 3 is BO, and then 3x minus 1 is this. All right. So they tell us the ratio of similarity of triangle boy to triangle girl is 1/2. So what that means is like this one is double the length of this one. So that would mean what I would do is to get from like here to here, scale factor 2, I would multiply x plus 3 by 2, and then I could set it equal to 3x minus 1. Right? A ratio of 1 to 2 just means like for every like 1 unit we have here, we have double that over here. All right. Just so we know this notation, like this like has the same meaning as like 1/2. Okay. Like 1 to 2 ratio. All right. So then what we do here is we just distribute. So this is 2x plus 6 equals 3x minus 1. And this would tell us x is equal to 7. Actually, just do that off to the side here. And then plus 1, plus 1. So this makes x is equal to 7. And then we want the length of GR. So I just plug in x equals 7. So 3 times 7 minus 1 is going to give us 20. So 20 is choice 4. Alrighty. So that is that one. I just want to double check something here. Let me just see. Oh, wait a minute. I'm sorry. Wait. Let's rewind. Oh, wait, no. Wait. I'm just want to double check. Key rating guide. Something about. Oh, no. 20. Yeah, 20 we're good. I'm just going to move on to 21. For a second, I was playing with the idea like they were trying to throw some extra trap in, but no, we're good. Okay. Question 21. We've got, a lot happening. Okay, so this is a little crazy. So DC, so we have all these chords. So DC, AC, DOB, CB, AB are chords. Great. All right, so here we go. Here's something useful. So this one is tangent. Tangents make a 90-degree angle to the radius. So like, see this radius here, DO? I just know right away when they say tangent, like this makes 90 degrees. So that's going to be useful at some point. All right, radius AO is drawn. Sam decides to apply this theorem to the diagram. So let's see here. An angle. Oh, yeah, good. I did bring a bottle of water with me. I just realized I've been talking for like over an hour. And yeah, it's a lot. Alrighty. So let me get back to the chat here. See how everyone's still with me. All right. So where are we? All right. Sorry, I just lost my place for a second. All right, here we go. This theorem: an angle inscribed in a semicircle is a right angle. All right. So that would apply to. Let's see. An angle inscribed in a semicircle. So we have this radius over here, which makes like, this is like really our only diameter. Okay, maybe we could find another diameter here, but here's one of the diameters we have. And there's no inscribed angles on this side that use this diameter, but we do have, if you pay attention over here, this one. See this angle here? Is an inscribed angle that meets both endpoints of the diameter. And remember, inscribed angle theorem. So when you have an inscribed angle, like let's say this, like whatever this one is, 2x, like this intercepted arc. So this one here is 2x. This one is half, is just x. Okay, so if we have a diameter, that tells us then the intercepted arc over here is 180 degrees. So that would mean this is half of 180 is 90. So that's referring to angle DCB, choice 3. Oh, wow. So what they did here, this is extra. This is a distraction. Sometimes they just like make a Regents question. They're like, oh, let's just draw 1,000 lines in there. Let's make it hard. Like why? Like why? But to make it distracting. Okay. So, all right. Here we go. Altitude rule coming up. So you ready? Altitude rule. I'm going to write out some stuff here. Know this. Big time. It's definitely on your Regents tomorrow. Well, I hope it is. If it's not, I'll feel bad. All right. Part 1, Part 2. And this is the altitude over here. Okay. So like this part here is the altitude. The hypotenuse is AB. All right. So hypotenuse AB. So altitude rule. I think it's easier to memorize this rule. Altitude rule says part 1 over the altitude equals the altitude over part 2. Okay, so that's that one. Leg rule, remember, don't skip leg day, is, we would say, I skipped leg day. Hypotenuse over leg 1 equals leg 1 over part 1. So if you forget this, what you could do is draw the triangle separately. So like that's like your payment for forgetting like what's going on here. You just draw them separately and in corresponding order. All right. But that like just, I don't know the rules for tomorrow if you could help it. So great. So here, which lengths would not produce an altitude that measures 6 square root of 2? So really we're going to be using the altitude rule here. And if we cross multiplying would actually make this, I think, work out easier. So we need part 1 times part 2 to equal the altitude squared. Okay, if I do part 1 times part 2, that's just part 1 times part 2. Altitude times altitude is altitude squared. So if we want an altitude that measures 6 square root of 2, I'm just going to plug this in just in case you don't want to do that math yourself. 6 square root of 2 is the altitude. And then we square it, and that's equal to 72. Okay, so if the altitude equals 6 square root 2, the altitude squared is equal to 72 via the calculator. If you're like, hey, I want to reach enlightenment, how do you know that? Well, all right, here's a little background math. 6 square root 2 times 6 square root 2. I just multiply these first. 6 times 6 is 36. And then if I do square root 2 times square root 2 is 2. And then 6 times 2 is 72. So that's where 72 is coming from. So really all you have to do then is see, all right, which part 1 times part 2 gives me an altitude squared, which equals 72. So like that's how I'm approaching all of these answer choices here. All right. AD and DB are part 1, part 2. But be careful here. I'm going to point something out. So you see, like, this one works. Now, you might say, like, oh, 3 times 24 is 72, but, like, bear trap over here. Okay, this one actually doesn't work. Because, see what they're doing? AD is part 1, is 3. But AB is the hypotenuse. So if the whole hypotenuse here, this entire length is 24, then this piece over here would have to be 21. All right, you'd actually have to do 24 minus 3 to find part 2. So part 2 would be 21. Okay, and if I did 3 times 21, that would give me 63, not 72. So that's why this. All right, AD times D, so 6 times 12 makes 72. And then AD, hypotenuse of this, 17 minus 8 is 9, and 8 times 9 is 72. So, like, these are, like, cruel, very cruel with the details. Just know the bear traps are most likely to show up in the last 4 questions. All right? The last 4 questions are usually, like, some of the toughest. So just be aware of that. All right. Oh, wow. 2,600 people have stopped by. Almost 2,700. Thank you so much for joining. And anyone who just joined, if this is helping, please consider subscribing. Help me grow this channel. I just want to keep pushing it, more and more. Alrighty. So let's see here. Moving on to the next part here. Question 23. We're an hour and 14 in. All right, I'll maybe pick up the pace a little. A designer needs to create perfectly circular necklaces. The necklaces each have a radius of 10 centimeters. All right, so this one we need circumference here. So if the, like, pretend this is a circular necklace and radius is 10 centimeters. And the person making the necklaces like has 1,000 centimeters. So this is like one, let's say this is 1,000 centimeters. I don't know, not necessarily drawn to scale, but just bear with me. All right. So here, basically, like, if you think about it, if we find the circumference of one of these, like, let's say, I'll go with this color. Like, whatever this is, the circumference, like, imagine I have, like, this much, and then, like we cut it, and then make it into a necklace. So the circumference tells us how much wire, like, we're going to cover. And circumference is equal to 2 pi r. Circumference is also pi times diameter, but here I'm going to use this one because we have the radius. So I just want to use the formula that's more direct. So circumference is 2 pi times 10 centimeters. And now I just asked the calculator. So let's see. So 20 pi is this, but I have to take 1,000 and divide by this. So 1,000 divided by, hit the up arrow and then press enter. All right. But we have to be very, very careful here. This is like I said, bear traps at the end. This was such a cruel Regents. This is back when they had 2 6-pointers. Now they only have 1 6-pointer. So just, they made it nicer. When the Regents first came out, like, they made it, like, pretty bad. So you might say, like, ooh, round up, 0.9 means 16, but, like, this is, like, LOL. No. Bear trap. All right, please be careful. You're not going to give someone, like, 0.9 of a necklace. Like, you need more than 16 to make a 16th necklace. So here you actually have to round down. This is, like, one of those real-world roundings, not the, like, rounding like you did in 4th or 5th grade. So just, yeah, sorry about that. All right, similar triangles that are zigzagged, okay? So similar triangles. How do I know? Because they told us angle C is congruent to angle OTU. And this angle is shared. So then I'm like, oh, this is angle, similarity. And that tells me corresponding sides of similar triangles are in proportion. So now we label this. So let's see. TU is 4 units long. We'll go green here. So TU is equal to 4. And then OU is equal to 5. So OU is equal to 5. OC is equal to 7. Okay, what is the length of ST? So I'll put an X here. So that's the one we're looking for. So for this, the key is similar triangles. Draw them in corresponding order. So you ready? See how this says like C? I'll write it like this. I'll do small triangle like O. Actually, here, I'll do it like this so it's neater. OTU. So this one, see, that is triangle OTU. However, when I redraw the bigger triangle, so here's the bigger triangle, I write the letters in corresponding order. So you see O is the one that is like unlabeled. So that would correspond to S. T and O are congruent. Oh, actually, I was just joking here. Hey, you know what? That's why it's good we go over this. Let me just fix this here. All right. Yeah, because it was like colliding a bit, covering that letter. Let's start this over. How about I start with the one that matches? T and C are the same. Angle C and angle T. So here in the small triangle, like T is here, that would be C in the big triangle. See, T and C are the same. They share angle U. So I would put U over here. So this would be C, U, and then this one would have to be S. Okay. So that's how we would set this up. So let me just double check. C, U, S. Okay. C, U, S. Wait, actually, no. So last question, sometimes you got to think a little bit more. Because I already did this whole Regents. I got all the questions right. So yay, 100. But when you're live, it's like sometimes you like need a second to think you're explaining it. So this is good. Let me model my thinking. I really take my time here. So this one, all right, I'm seeing the big triangle needs to be flipped. Like if I flip this big triangle this way, like a vertical flip, that'll put S over here. Then it's going to put C at the top and U over here. I think that'll do it. Yeah, they share angle U. And then, let's see, T and C are the same. Yeah, T and C are the same. See, those are the ones that are labeled. T and C are the same. And then S is at the bottom now, and that corresponds to O. And U is the one they shared. Okay, great. So corresponding, like put the corresponding angles in the same position. And then that'll help you set up the ratio. So now I'm going to put the labels back in. So CU is 7 plus 5 is 12. And then, let's see, TU is 4. And then SU is X plus 4. And then OU is 5. All right, so now I could set this up nicely. I could say, all right, something like 4 over 5. So this side over this side is equal to 12 over X plus 4. So the whole battle here is just set this up carefully. There's a great quote by Abraham Lincoln. You give me 6 hours to chop down a tree, I'm going to spend 4 hours sharpening the axe. So I was just really sharpening the axe back there. Big time. But now that it's sharp, then this question isn't so bad. 4 times x plus 4 times 4 is 16 equals 5 times 12 is 60. And now just don't mess up the algebra. 4x equals 44. So x is 11. All right. What is the length of ST? ST is labeled with an X, so 11. Great. No, don't fail. Do get hundreds. All right. No, if you don't get 100, it's okay. But yeah, part 2. Yay, we're out of the multiple choice. So the triangle ABC. Oh yeah, 2 points, 4 points, 6 points. That's how it goes. All right. So here. Triangle ABC is graphed on the set of axes below. Graph and label triangle. So we have to graph and label triangle A prime, B prime, C prime. The image after a reflection over the line x equals 1. So x equals is a vertical line. So x equals 1 would look like this. And when you reflect, just count boxes. So 1 to the right, and I go 1 more. That would be B prime. 1 to the right, 1 to the right. Now this one I have to go 1, 2, 3, 4. 1, 2, 3, 4. Please, whatever you do, before you say that's my answer, make sure it looks the same as the original triangle, because a reflection is a rigid motion, which means the new triangle should be the same size and shape as the old one. So there is the new one. We didn't have to write the coordinates. They just said graph and label, which we did. So yay. All right. Great. So this one is one of those brute force questions. So we have diameter BC. That means it goes through the center. Okay, so we have this. Radius OA goes from the center to the end. All right. Oh, then we have this one. DC is parallel to BA. And BCD is 30 degrees. So this one is 30. All right, so now like we have so many options here. So inscribed angles. This arc, see, like is over here. I think of this as like pizza. Like the intercepted arc is like the crust of the pizza slice. Like if, please don't ever cut a pizza like this. But let's say you cut a pizza, like you cut your slice all the way like this. That would just ruin the pizza. The crust would be this part. And that's the intercepted arc. And the intercepted arc of an inscribed angle is equal to 2 times that. So this one would be 60 degrees over here. Okay, so this one is a 60-degree arc. But then when you have parallel lines inscribe congruent arcs. So arc AC over here would also be 60 degrees. And then that would tell us the measure of angle AOB. Well, if this one is 60, because central angles equal the arcs they intercept, the measure of angle AOB would be 180 minus 60. Because they're like, hey, this is a diameter, which makes a line. So the measure of angle AOB would be equal to 120. All right, nice question here. Got a cool. Yeah, I'm definitely bro is Italian here. Never cut a pizza like that. That's like something like people go to an Italian restaurant and they just put ketchup on, like that would really piss them off. Like they don't even have ketchup in Italian restaurants. That would be like what are you doing? Like that's like an insult to the chef. Like what, my sauce is no good? Like you got to put ketchup? All right. So directed line segments, formula. If you can remember this formula, then great. How about I don't know, you could use M and N, but sometimes like you write M and N, they kind of look alike. So maybe P and Q. Doesn't matter. It's all the same. So this one helps. If you have this memorized, x1, y1, x2, y2, and then you just plug in. So I would say, all right, x equals x1 is -2. P and Q is like the ratio part. So like 2 to 1. This is like the first part of the ratio and the second part. And what I think of for this is if I have a line segment and I'm breaking it into a ratio of 2 to 1, that's 3 equal parts. Okay, 3 equal parts. 2 to 1 would be like over here. So you have 2 equal to the left, 1 equal to the right. And then that would be 2 over 2 plus 1 is going to give us 2/3. And then subtract 4 minus -2. Okay, and then times 6. And then this is -2 plus 4. So x is equal to 2. So the x coordinate we're looking for is going to be 2. And then to find the y value, do the same thing, but just y1. So 1 plus still 2/3. And then y2 minus y1, 7 minus 1. Gives us 1 plus 2/3 of 6 is 4. And 1 plus 4 is 5. So our point, J, would be 2, 5. All right, that would be our point. Now, I don't get it. That's fine. Then use the formula. I'm sorry, just joking. Use the graph. So -2, 1 is over here. And t is at 4, 7. So 1, 2, 3, 4. Up 1, 2, 3, 4, 5, 6, 7. Oh, I said it again. All right. It was really hard to teach this year with that whole 6, 7 craze. Not easy. Like I had to figure it out in September. I'm like, why is everyone laughing like at nothing? And then I was like, oh, I mean, I'm all for mindless jokes like that. Like that's like within like 3 degrees of my actual humor. But yeah. So let's say you can't memorize this. Like, oh no, I forgot this. So like this is like I forgot that formula. Oh no. Then rise over run. You ready? So to get from P to T, I go up 1, 2. So let's see, 1, 2, 3, 4, 5, 6. So I go up 6, and I go over 1, 2, 3, 4, 5, 6. But what did I say before? Concepts. So this is the concept. Is a 2 to 1 ratio makes 3 equal parts. So 3 equal parts, like, all right, what if I divide by 3? Well, then I go up 2 over 2. So you already watch what happens if I go up 2 over 2. So up 2 over 2. Up 2 over 2. And notice we have 3 equal parts. Okay, and 2, 5 is over here. And this is the one that breaks this into a ratio of 2 to 1. So 2, 5 is good. I'm trying to teach the whole year at hyper speed, or at least in 3 hours. 6-point question tomorrow is either going to be how about we say a coordinate geometry proof, okay? Not the statement reason. This is how it goes. Are you ready? So the 6-point question is either coordinate or statement reason. And then if the 6-point question is coordinate, then the 4-point is going to be a triangle proof, or vice versa. All right. So cool. All right, moving on. Rigid motions. So here, this one was a little wacky. Is this triangle congruent to this one? So we have to say yes or no. Use the properties of rigid motions to explain. So here it looks like reflection first. So reflection, let's say I go here. See, I go over. So over 1. Then I go over 1, 2, 3, 1, 2, 3. And then I go over 1, 2, 3, 4. 1, 2, 3, 4. And that brings me here. Okay, and if I connect all this, see, this would be reflection over the y-axis. A reflection is a rigid motion, which means that triangle is congruent to this one. And then I translate down 1, 2, 3, and you see how it maps perfectly onto this. Okay, so I would say, yes, they're congruent. And how do I explain that with properties of rigid motions? I would then write out a nice sentence here, okay, which yeah, this is a tricky topic. Someone asked before, like, oh, what do I do? But the best advice is, like, sharpen the axe first. Remember, chopping a tree down, it's going to take you 6 hours. 4 hours, you should be sharpening your axe. Like, think about it. Like, this has to flip, all right? It has to reflect first. The way I know it reflects is, you see how, like, if I go in a circle, it's like A, B, C, A, B, C, A, B, C. But if I go in a clockwise circle, I have A, C, B, A, C, B. That shouldn't be. Like, the orientation changes when you reflect. So that's how I know a reflection happened. And then I'm like, oh, just translate now, and that'll get me there. All right, there's not just one right answer. There's a lot of ways you could get there. So I would say, are these two congruent? I would say yes. Okay, first. And then how do I know? Well, I would say triangle A prime, B prime, C prime is the image of triangle ABC. After, and explain the reflections or the transformations I did. After a reflection over the y-axis, followed by a translation 3 units down. So followed by a translation 3 units down. Okay. And now I have to actually comment. We have to explain our answers. This is a lot for 2 points. This should have been like more than 2, but whatever. I don't make the regents. So how do we know? I would say, all right, a reflection, because these are the ones that were done. These two are rigid motions. Okay. So a reflection and translation. You know what? I'm going to write this sentence a little bit different. Reflections and translations are rigid motions. So distance and angle measure is preserved. They love that phrase on the Regents. Like, if you write that tomorrow, the person grading your paper is going to be like, ooh, I've heard that so many times, +2. Like, and you just get the credit. If you try to get too creative, then they're like, what are you trying to say, kid? And then they have to, like, try to find you points. So distance and angle measure is preserved. Therefore, I promise this means therefore. Therefore, triangle ABC is congruent to triangle A prime, B prime, C prime. Hard question for 2 points. All right. All right, let's just see. Wait 1 second. All right. I just have to. Yeah. Okay. Moving on. So. Moving on to question 29. So this one, length of the ladder. All right, so here's like a ladder leaning against a house to reach the bottom of a window, 30 feet above the ground. And we have to find the length of the ladder. So this is the ladder over here. So I'll put an X here. And this 30 feet is also like this one over here. So it's right triangle question. This is like a classic 2.1. So this one here, if we have a 70-degree angle over here, this side here is opposite. So this is opposite. And then the ladder would be the hypotenuse. Okay, so when you hear opposite hypotenuse, so SOHCAHTOA, Opposite hypotenuse, you should be thinking of the sine function. All right, and then we just say sine of the angle, that looks terrible, okay, equals 30 over x. All right, yeah. Oh, people, just friendly reminder, this chat has been like mostly awesome, but I wrote a little disclaimer on the side. Like if you say anything like, you know, foul, hate speech, bullying, whatever, or like anything like super political, I just mute you for the rest of the chat. Okay. Like that's just it. Like then you just like lose the like privilege of typing in the chat. So please, like, yeah, most of like 90 something percent of you are like keeping it real, but just, yeah, just being mindful of that. Like I don't even like announce it. I'm just like, oh, mute. So I'm like doing the math and I'm like casually like silencing, well, I don't want to jinx it, but, you know, trolls and stuff, but this hasn't been too trolly of a live stream. I've had some where it was like pretty exhausting, you know, swatting the trolls, but okay. So here, there's a nice little algebra technique you could do. This is like the harder version, but you could just swap these two. So you could switch x with sine 70 and say 30 divided by sine 70. Okay, it's really nice when what's it called? Like you're not looking for the hypotenuse, because then when you cross multiply, you're just done. But you could just swap these two, and you get 30 divided by sine 70. So 30 over sine 70 is this number here. Okay, so this is equal to 31.925. But be careful here. Determine to the nearest foot the length of the ladder. Okay, so I'll just say here, like, all right, the length of, let me fix that, of the ladder equals 32. Okay, if you want to say, what was it? Is it feet? Yeah, feet. You could say feet, but don't risk writing the units. If you write the wrong units, you lose. All right. Oh, happy to help. I'm very happy to help. So I'm trying to read the chat too. But yeah, that's I'm glad you're appreciating this and getting something from this review. All right, this one, more density, population density. So remember, density equals the mass over the volume. But population density, population over, you could even think like population over the area. So that's where my head goes here. So I wouldn't, like, I just think of this. I'm like, all right, like density equals mass over volume, but you could say like the population over the given area. And that's what I find. So here, though, it's a circle. And, diameter, again. Wow, they're really going heavy with circles. So diameter is 51 millimeters. So I do 51 over 2. So that'd be 25.5. So I'll call that R1 for, like, our first radius. And then R2 would be 75 millimeters divided by 2, which works out to 37.5. Okay, just double checking. Yep, that works. Cool. So then here, the tricky part is, like for A, we're doing population, 40,000 bacteria. So that's like our population. So we're doing 40,000 divided by pi r squared, because this is a circle, the Petri dish. So pi times the first radius for R1 is 25.5. So 25.5 squared. And that's what we're dividing by. For B, Petri dish B, we would do, this population is 72,000. But over pi times the radius here is 37.5. Okay, remember, I'm also thinking like, oh, area of a circle is pi r squared. So like, there's a bit to do here. And now just type this in. All right, so alpha y equals enter. And then 40,000 divided by pi. And not cosine, press the wrong button. 25.5 in parentheses squared. Okay, I want to point something out. Please, whatever you do, do not do this. I see this all the time. People go, oh, this divided by this, 25.5 squared. And then they're like, oh no, the calculator's broken. And I'm like, no, the calculator's not broken. You're broken. The calculator reads this differently. You would have to, if you don't want to use alpha y equals enter, then you divide by parentheses pi times 25.5 squared. Like you have to do the denominator in parentheses, and then you get the same answer. All right, so just be careful. Alrighty, so then next fraction is 72,000 divided by pi and then 37.5 squared. All right, and that will bring us to this. And now I just write this out, the densities. Okay, so here, the density of A, I'll just write out, is 19.58. I'll just round to the nearest hundredth. Actually, you know what? I'll go to 1,000th because, yeah, 5/8, and then to the right is of the 0 is a 1. And then this one is 16.297. Okay, so then this one, like which Petri dish has the greater population density? I'll say Petri dish A. Okay, because this is greater. All right, so that's it. It is A, in fact. Question 31. We are making progress. This is our last one. Our last 2-pointer. So line dilation, yet again. I hope they put one tomorrow because now you know how to do it. So here, line L is mapped onto line M by dilation centered at the origin, scale factor 2. All right. So for this one, first thing I check in my head, if the center is 0, 0, I plug this into the starting line to make sure this is not on the line. So I do 3 times 0 minus 0 equals 4, and then 0 minus 0 equals 4. This is not true. So not true. Which tells us the center is off the line. Which means we are going to get a new line. Sometimes the line doesn't change and they're like, gotcha, but not here. All right, so for this, first I would solve for y. So just think y equals mx plus b. And this is your slope. And this is your y-intercept. Okay, so this, I could go plus y on... Actually, you know what? I'll do this. How about I go minus 3x? Yeah, that works. I could do that too. So we get minus y equals negative 3x and positive 4. And then just multiply everything by negative 1. So then y equals positive 3x minus 4. So now what this tells us, just so we get the concept down, my best advice for these questions is like note, dilate the y-intercept. And remember, dilated lines are parallel. So the slope does not change. The most common mistake in the world is when they scale by factor 2, kids go, oh, y equals 6x minus a. Like, LOL, please don't do that. Bear trap. All right, don't do that. That's really bad. Don't just double anything. The slope stays the same. You're like, wait, how do you know the concept? So here's 0, 0. This is our center. And the line 3x minus 4 would be like, I don't know, let's say like some line like this, like positive sloping like this. So when I dilate by, let me just move this down like this. If this is at the point 0, negative 4, so that's our y-intercept, negative 4. If I double the distance here, so this goes out here to negative 8, and the slope doesn't change. See, so this would be the line. So then, like, I would go to y equals 3x minus 8. Okay, but the math that you could do is you say, all right, like, the y-intercept is at 0, negative 4. So I dilate this. That doesn't mean the point 0.02. This is like, I'll just say like O for origin. And then this is like our scale factor. And that would, I would multiply the x and the y by 2 to go to 0, negative 8. So that's why my y-intercept becomes negative 8. No, if the dilation is like on the line, then the equation doesn't change. Okay, so just, yeah, that be careful of. Like if it was, like let's say 3x minus y, like if it was just y equals 3x. So if y equals 3x, that would be something like this. So when I dilate and my center is on the line, like all my points would stay on the same line. So like that would be like my original. And my answer would be y equals 3x. Like, does not change. All right, if y equals 3x or something. Okay, but that's not what happened here. So tricky concept, I know. 32, part 3, questions are worth 4 points. This one was kind of weird, but it's like more ratios. Ratios is very big. So TV, the ratio is 16 by 9. Which most TVs are. That is the aspect ratio. All right, and make a nice widescreen TV. All right. So here's our TV here, nice rectangle, and we just have to like really think. Maybe not a perfect rectangle, but you get the idea. All right. So for this is 9 by 16. So like if I put an X here for now, like 9X and 16X, like we don't know how big this TV is, but we'll find out. But they told us, let's see, the length of the diagonal is, all right, so this is big. Yeah, and that is true. When they tell you that like, oh, your TV is 65 inches, that's like the diagonal length. So you learned something if you didn't know that. Okay, so this is the size of the TV, is like the diagonal length. That's what we're solving for. But they told us, ready, here's important stuff. The height is 20.6 inches. So the height is this. So 9x I could make equal to 20.6. All right. Anytime you get a ratio, it's a good idea to like multiply each part by x and then label your diagram with that. But when I want to solve for the x, I just divide both sides by 9 and I get this 20.6 over 9. Okay. And then that, just type that in a calculator. Okay. I think you're okay. Like just divide, like that's not something crazy, like nothing super technical. So this would tell you x equals like 2.2888 repeating. Okay. This like 8 just repeats. All right. But now that we have that, what we could do is we could say, all right, well, if the height of the TV is 20.6, so this is 20.6, this part. We could solve for the width by doing 16 times x was 20.6 over 9, or 2.2888 repeating. So let's go ahead and do that in the calculator, and then I'll do Pythagorean theorem. All right, let's see. All right, I'm sorry, you get 16 times x. And x is 2.2, and then a bunch of 8s. I'll just write a bunch of 8s. That'll get the message. So 36.62222. All right, so that's 36. Wait, why did I change screens? 0.6, and then a bunch of 2s. All right, but then to find this, see, I have a rectangle. I use Pythagorean theorem. All right, so this will tell me now. So I write out the work. 20.6 squared plus 36.6222 squared is equal to, I'll put an x here. Oh, not x, because we already used x. See, I was just testing you. Maybe y, so equals y squared. And then just take the square root of this. And say like y equals to the nearest inch. So I'm going to round to the nearest whole number. So you ready? Which question would you like explained more in depth here? Is there any trick for memorizing how to use triangle congruency proofs? All right. When I get to the triangle proof, I'll like go into like how I know which one. Where did 20.6 come from? Oh, they gave us that. They said determine and state to the nearest inch the screen size diagonal with a screen height of 20.6. Okay. So here, square root of 20.6 squared plus 36.62222 squared, 42. So this is a 42-inch TV. Very nice. Okay, so 42 is our answer. Alrighty. If you want to like play it safe and write like a few things out, like 0.184, like you like here you can even leave this part out, even like just be like 42, like just to show where you're getting your work from. Like it doesn't matter. All right, this I'm gonna say is slightly outdated, but maybe it's coming back. Maybe, I don't know. So this one, it's a nice proof. It was a fun idea, but they're like, hey, prove that the sum of the angles inside of a triangle is 180 degrees. But they gave the statements and they left the reasons out. This is the only part that's outdated. So this is like a little outdated. Like I haven't seen this one in a long time. Because this was like when the Regents was new, so they were like overcooking it a lot. And then like it made a lot of kids upset, so they like started cooking it less. Okay. Alrighty, let's see here. So this one, so through point C, so we have triangle ABC. They want us to prove the sum of the angles is 180. So they draw this line in, and you're allowed to draw a line in like this. So you see how they're saying like, oh, we drew this in such a way that it's parallel to AB. And you could do that, and it's actually called a parallel line postulate, but what we could say is to a given line. Okay, so to a given, actually, you know what? I'll say it a little different. So how about, I like this one more. Through a point on a line, exactly one, oh, I'm sorry, through a point not on a line. Let's say that. Through a point, because the point not on the line is C. So like I'm referring to AB. So through a point not on a line. And then I'll explain what I'm about to write like after. Through a point not on a line, exactly one point oh, I'm sorry, wait. Through a point not on a line, exactly one parallel line can be drawn. I want to. This is like awkward to phrase because I don't want to just say like parallel line postulate. You know what? All right, I'll say. All right, I'll say one more take. Okay, so I'm sharpening the axe. Right, I already said that a bunch. So to a given line, there is. Oh, yeah, this is better. To a given line, there is one parallel line that can be drawn through a point not on through a given point not on the line. Okay, so through a point not on the given line. And let me just like explain that. All right, I know, I'm sorry, that took a while for me to get on the paper. So to a given line, so the given line here is AB. There is one parallel line that can be drawn through a point not on the given line. So yeah, if I just have like a line here and a point like this, I could draw exactly one line that's parallel to this through that. So you're basically in too long didn't read or simple language is like, hey, like if you have a line and a point off the line, you can make a parallel line. So cool. But now let's think about this part. Angle 1, the measure of angle 1 is equal to the measure of angle ACD. So they're saying like, oh, these are the same. And then they're saying the measure of angle 3 is equal to the measure of angle BCE. These are alternate interior angles. So that's like why they made the parallel line. So this comes up a lot when parallel lines are cut by a transversal. So when parallel lines are cut by a transversal, the alternate interior angles formed are, I'm just checking the time too. How long am I? So I'm like, my head's a little, oh, an hour 36? Is that, oh no, wait, this is, oh, an hour 55. That's the live time. All right, so we're at 2 hours. So when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. Yeah, this is a tough Regents. So, all right, now here we have this. The measure of angle ACD. So you see the measure of angle ACD is over here. So that's this one, plus the measure of angle 2, plus the measure of angle BCE equals 180. And that's true because they make a straight line. Okay, so I'm just going to write out the sum of the angles on one side of a line equals 180 degrees. Okay, which is like just reviewing like key ideas. The sum of the angles on one side of a line equals 180 degrees. But now notice what they're doing. They're substituting. See here, they subbed. Okay, just like everyone here should subscribe. Okay, so ACD equals angle 1 and BCE equals angle 3. They made a substitution. So for this, just substitution. And it's cool. This actually proves that the sum of the angles inside of a triangle makes 180. Cool. All right. This is a little outdated, though, so don't be too scared. Constructions. All right, you ready? So they want us to, for this one, use a compass and straight edge on the line below. So here's the line below. To construct triangle ABC such that triangle ABC is congruent to this one. So I'm basically copying that triangle. And I have Smart Notebook weighting with this. So this one is a little outdated in the sense that it was 4 points. Most of the constructions I've seen in the recent years are 2 points. But this one would just copy a line segment. Okay, so if I'm copying a line segment, I'm just going to draw a point to start on the line over here. So I'm going to like say, oh, that's my reference point. So like this one would map to this one. And I'm going to copy this first. So I go from here to like open this up and I measure. So like that would be the distance from X to Y. And I place this over here and I go, all right, that distance from X to Y. So you see like this part here matches with this. And you see how like I look at the letters, like Y is the second letter, B is the second letter. So this I'm going to call point B. All right. And then X was letter number 1 and A is letter number 1. So this would be like my letter A. So here's A and B. Now I have to find like where is point C. Now I could do this like the easiest way is like side, side, side. I just, I'll show it like, yeah, 2 ways. So I copy this one, then I just copy all the sides. So I go here. Sorry, this is like getting out of the picture a little. So I measure this distance from like here to here. So I could do this. So like, all right, so that, and then X corresponds to A. So I go back to point A and I go like this. And then I would measure the long side from Y to Z. Okay, so this is like probably the easiest way to do this, to just copy all 3 sides. So, and I have to put the marks on the paper. So like this, and then I go here, and then I'm like, all right, there's the third one. And then I go like this. So here, and then here, and then here. All right, and then I would put point C over here. So like that works. But maybe I'll show copying an angle because I feel like people are more likely to forget copying an angle. So like, let's say tomorrow is copy an angle. Because copy a line segment is like kind of simple. So let's say like I just copy this. But now I want to copy, whoops, wrong button. I want to copy angle Y. So this is option 2. So I just showed one way, and you can rewind back to see it again. So I copy this over here. Like that is not going to change. That's going to be the same. So I copy the side, and then I could copy the angle. Okay, so if I want to copy this angle at Y, I make this small enough so that when I swing the arc like this, see it hits twice. 1, 2. And now Y corresponds to B. So I go over to B, and I do the same thing, like swing the arc like this. Then I measure. I measure the distance from here to here. And I go like that. So 1. And then I go to this same point here on this reference line. And I go 2 like that. And what that did is it just made my angle that I'm copying. So like this angle here, I'm going to go really far out, is equal to Y. Like AB, whatever this is going to be equal to this angle. But then I just copied this side and this angle. So I'm going to copy side, angle, side. And then that'll make the triangles congruent by the SAS postulate. I'm sorry, side, angle, side. Yeah, theorem. Postulate. Wait. Let's see. So here, although they did say state the theorem, so I'm gonna say side, angle, side theorem. I'm pretty sure that's a postulate. Let me see. SAS postulate. Oh wow, yeah, they should have said postulate, not theorem. So New York -5 for you for using the wrong terminology. Yeah, it should have been postulate, but they said which theorem. Okay, so what I just did was I copied the distance here from Y to Z over here. And now what that does is I just connect this to this. And now that's going to tell me where point C is. Okay, so this is point C. But this was like an old region, so like, hey, why are these congruent? So I would say triangle ABC is congruent to triangle XYZ by the side, angle, side postulate. All right, -5 New York. It should say postulate, not theorem. All right, a postulate is like something we just like accept as truth because it's like so undeniably obvious. Whereas a theorem is something we prove with the postulates. Okay, so this would see, you could see like, yeah, they're looking the same here. So that works. All right, enough constructions here. Moving on. Oh, part 4. All right, this is when there was 2 6-pointers. So there's like one here and a trig 6-pointer, which is like awful. All right, so we're going to end in style. This proof is actually like really bad too. So sorry. All right, let me just get to it though, because time is precious here. Oh, we're at 10 o'clock. That's not the worst. Late regions tomorrow. If you haven't subscribed, consider subscribing. Help me grow the channel. I am trying to get to 50,000. Oh, wow, we're at 49,905. 95 more subscribers, and I hit 50,000. Please help me get there if you haven't subscribed. It's so cool to be that close. 50,000, I don't know why. That's like an exciting milestone. I mean, 100,000, you get the play button, and then I'll put it behind me. But, yeah, that's the halfway point. But my first year, it took me a year to get like 100 subscribers when I was new. So, yay, someone else subscribed. Thank you. All right, let's move on here, though. We're not here to talk about YouTube history. All right, statement reason. This one is like really, like, it's kind of bad. I could show you the model responses, but I don't know. Maybe I'll just write it myself from scratch. Statement reason. Okay, cool. So one is just always the givens. You could abbreviate parallelogram by drawing this. So parallelogram, ANDR, and I'll say like AW and DE, bisect and You know what? This one, yeah, I guess I got it right over here. NWD and REA. I did it a little different than the model response, so like bear with me. But this is like a little bit old, this style. So I'll show you the model response too when you're done. When I'm done with this. Respectively. All right, this is true because given. All right, this is just a lot annoying to write. You have to write the givens though, so don't forget it. But now let me translate this. So this is a parallelogram here. AW bisects NWD. So that means these two are the same. And then they tell you DE bisects REA. And opposite sides of a parallelogram are equal. So like these four segments are the same. But we have to like explain all that. All right. And we're told, hey, this is a parallelogram. So that means like these sides are also the same. Parallelogram also allows us to say that opposite angles are equal. So now I know these triangles are going to be congruent by SAS. So, Nathan, before you said like, hey, like, how do I know when to use SAS or like which proof to do? I use tick marks. Once I get tick marks on the page, then I look and I'm like, these triangles, like I see that and I'm like side angle side is what I'm doing. Not this. Don't ever write ASS on your paper. It's such a bad word. I'm not going to say it. But that at least gets us going here. All right, so now the fun part, writing all this craziness. So first non-obvious statement here, I'm going to say AN is congruent to RD. And I'm going to say like, yeah, AN congruent to RD and AR congruent to ND. And how do we know? I'm going to say opposite sides of a parallelogram are congruent. Every smart thing you say, like you get credit. So like try to say a lot of smart things. Opposite sides of a parallelogram are congruent. Like that's something if you say like is good. Like that's like a non-obvious thing. Maybe you want to mention the angles too. Angle R is congruent to angle N. So angle R is congruent to angle N. Reason opposite angles of a parallelogram are congruent. All right, this will get you partial credit. Like that's what people look at the 6-point proof and they're like, "Oh, I got to say like everything." So I'm just like, it's too hard. I'm not going to say anything. And I'm like, no, like say like a few smart things and get partial credit. All right, that's better than nothing. All right, now this is where things get a little less obvious. Because like this line segment and this line segment bisect these two, I could say, I'm going to write it first and then I'll explain it. So I could say ER. And I'm pointing at ER because if I want to prove these triangles are congruent, say I want to prove ANW is congruent to DRE. I want to prove ER, like my goal, like where this is headed. I want to prove ER congruent to, so let's see, ER congruent to WN. Now, like that's my goal here. Like in some form, I want to say this. So in order to do that, like that's why I'm creating statements involving these. Like, oh, ER is half the measure of AR. And how do we know? Like, yeah, ER is half the measure of AR because they said like, hey, these line segments are bisecting the segments. So ER is 1/2 the measure of AR. And I could say NW because I'm trying to show like, I'll say WN so it's in the same order. That doesn't matter. Only at the end when you say the letter arrangement that it matters. And WN is half the measure of ND. Okay, so that's this. How do I know? Because a segment bisector separates a line segment into two equal segments. Okay, so a segment bisector. You can say like definition of a bisector, but a segment bisector. Oh, let me get rid of this now. Separates. Actually, should I? Yeah, I'll write that in the next line. Separates a line segment into two equal segments. All right, you'll see where this is going in a moment. Oh, hopefully. All right, but now let's think about what we could say next. So we already said, let's see here. So we said ER is equal to 1/2 AR, and NW or WN is equal to 1/2 ND. But where I could go with this is I could use the multiplication postulate. Okay, so I'm going to apply the multiplication postulate to this. So here we go. This is a hard proof, by the way. I picked one that was like really bad because I figured the worse, the better. So this, you see how AR is congruent to ND? So I could say that 1/2 the measure of AR equals 1/2 the measure of ND. All right, because I already stated this. Opposite sides of a parallelogram are congruent. So if I multiply both sides by 1/2, I could say they're equal. And this is true by the multiplication postulate. If equal quantities are multiplied by equal quantities, the products are equal. That's the multiplication postulate. So the multiplication, whoops. Let me move that over so I could write the whole thing. I don't want to write it in 2 lines. So multiplication, I'll just abbreviate postulate. Okay, multiplication postulate. Hopefully you see where this is going. All right, so then from here, what I could say is I'm going to make a substitution. All right, we're going to make a substitution here. So you see how we said ER is equal to 1/2 AR, and WN is equal to 1/2 ND. So maybe you see where this is going. I'm going to make the substitution here and say like, all right, ER is 1/2 AR, and WN, let me change colors. WN is 1/2 ND. So in the next line, I could just say ER equals WN by substitution. So ER, this is a hard one, this question. So ER is equal to WN, which in the same line, I'm just going to say they're congruent because I like to say congruent when I'm doing triangle proofs. And this is true by substitution. Yeah, this was like kind of annoying, this one. But this, like they kind of phase these out. All right. So now see what I said? ER is congruent to WN. So I said aside here, I said RD is congruent to AN. And I said angle R is congruent to angle N. So you see I established SAS. So now statement 7, I could say triangle ANW is congruent to DRE. So triangle ANW is congruent to triangle DRE by SAS. Remember, those of you looking at this right now, like, whoa, this is scary. This is the worst. For the 6-point proof, if it's statements and reasons, just try to say as many smart things as you can. All right? Like, don't just spam like vertical angles, like vertical angles, everything. Like, no, like parallelogram, be like, ooh, opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Like something relevant to the question. All right, like just try to do that. Cool. So now we proved the first part, but we have to prove part 2 of this. This is a real beast. We have to prove that AWDE, so that this shape is a parallelogram. All right. So, well, let's see here. We didn't say that AE is congruent to WD. You see, we said all this stuff over here, but you know what we could use now? Oh, this is good. It reviews everything. Subtraction postulate. So if I already said over here, ER. So ready for this? ER is congruent to WN. We said ER is congruent to WN, and we said AR is congruent to ND. Where is it? AR is congruent to ND. So this is where the subtraction postulate comes in. So you ready? So if we look here, if I did AR minus RE, see, like if I take AR and I cut this out, I'm left with AE. So AR minus RE. So AR minus, no, I'll say ER so it matches what we have over here. That's going to be congruent to, and if we scroll up, see AR minus ER is going to equal ND minus WN. And what does that give us, though? AR minus ER gives us AE. So that gives us AE. And what happens when I do ND minus WN? So ND minus WN gives us WD. So I could say these are congruent. And this is true by the subtraction postulate. When equal quantities are subtracted from equal quantities, the differences are equal or congruent. And what does that establish here? Well, AE is congruent to WD, has just told us we have one pair of opposite sides congruent. But now how do I know AW is congruent to ED? Because if I want to prove this is a parallelogram, I'm going to prove that both, and let me use 3 tick marks since we already have 2. So 1, 2, 3, 1, 2, 3. AW is congruent to ED because we proved these triangles are congruent. So AW is congruent to, let me just write it out. Let's see. So AW is congruent to, I said first and third, so I'll say DE because CP, CTC. All right, this stands for constipated people can't take craps. No, it stands for corresponding parts of congruent triangles are congruent. Okay, so that's how I know AW and DE are congruent. They are corresponding parts of congruent triangles. But now, what did that just establish? Now we have both pairs of opposite sides congruent. So I can finally say the last thing I'm trying to prove. Quadrilateral AWDE is a parallelogram. Oh, I have it on my paper over here. So quadrilateral AWDE is a parallelogram. The reason? Both pairs of opposite sides are congruent. Okay. All right, great. So, last but not least, yes, CPCTC, you'll never forget it. Constipated people can't take craps. Don't write that out. Say CPCTC and just know what it really means. That's just so you don't, now you'll never forget it. All right. So moving on here. If we look, all right, this was like extra, truly awful. This is a 6-point trig question. This is like really bad. I'm going to go over it though, because like I did say I'll go over the whole test, and I feel like I'm neglecting you if I don't. But the algebra, this is like they don't do this anymore because this is like scorched earth level algebra. Okay? So, yeah. Yeah, this is like a really bad Regents. I'm sorry. Like when I started doing the questions today, I was like, oof. Like, but I already committed to this one. Alrighty. So here, Kathy wants to, all right, here we go. This is the whole task. What is the height of the flagpole? So that's like the whole thing. So we want this whole thing here. All right, but we're going to chop this like here. Let me actually move that over a little. So they're not like, all right, so we have this. So we're going to have 2 right triangles. This one in purple. And this right triangle in red. I'll just draw it in like this. So there's this one in red. All right, there's a lot happening here. This one is pretty bad. All right, so right now they told us like, hey, this thing is 8. And I'm going to put an X over here. So in the red one, if I draw the red one over here, this is 52.8 degrees. And then this is X. And then this is like the mystery piece. So this one over here, I'm going to call Y. But not the whole thing, like just from here to here. Forget about that like 1.7. I'm going to pay that back later. Like this 1.7 is like extra. But the Y is what I'm interested in. Like I'm going to solve for that first. So that's the red one. And then the purple triangle is worse. This angle is 34.9 degrees. And the bottom would be X plus 8. and then y. So this is like, yeah, really old, like pretty bad stuff. So which function would I use? SOHCAHTOA. Well, for both of them, I would use tangent because this is opposite adjacent. Opposite adjacent. So tangent of the 52.8 degree is y over x. And tangent of the 34.9, opposite over adjacent, is this. Okay, now there's a few ways you could go forward with this. We really need to solve for y. So when I first did this, I did this like by graphing second trace, but I don't know, it's like better to show. I mean, they're all pretty bad, so whatever. I'll just show it like, you know what? I'll show you the way I did it, and then I'll show the model response, like how some kid did it. That was like pretty clever. All right. All right, let's see. So we're solving for y. So I want to get everything like to say like in terms of y. So here, how do I say this? What's the best way? Yeah, I mean, the way I did it was like really hard to type too. But all right, you know what? I'll just solve it algebraically, whatever. Then I'll show you the calculator magic after. So y equals x times tangent of 52.8 degrees. So here's like equation 1. And then this gives us, if I cross multiply, y equals tangent of 34.9 degrees times x plus 8. So I get here, I get these two equations. Now I'm going to graph both of them and see where they intersect. Okay? And the point of intersection is going to tell me what y is. So you ready? So here, calculator. They didn't say we have to do it algebraically. So if they don't say that, then we could do this. You ready? So y equals x times tangent of, make sure you're in degree mode, 52.8. And then this one is tangent of 34.9 degrees times x plus 8. And we're looking for the y. So if I graph both, I'm like, oh no, I can't really see anything over here. So then I could just like extend the window out. Like let's say I go out to like 50 and I go out to 50 here. So I just go out more. And there it is. Second trace 5 tells you where points of intersection are. Because that'll tell me like which x and y work. All right, so then this makes it a lot easier. Like if you try to do this algebraically, it's like pretty bad. But I mean, we could just look at a model response if you want to see. But I would just, oh wait, hang on. I mean, whatever. I'll just say, like if I'm showing my work, I'll just say like second trace 5 told me, let's see, like 9.0037141, comma 11.861955. Okay, and then I would say like, oh, this is what I want, like y. Like this is x and this is y. So that's what I want, but be careful here. Y is just this piece. The height of the flagpole was in green before, is like the entire distance. So I have to do y plus 1.7. So I would do like, all right, 11.861955 plus 1.7. Yeah, that's like the best way to do this. Okay, this is like, yeah, if they want to turn trig into a 6-point question, that's how they would do it. Just like ruin everyone's day. Okay, so this plus 1.7. All right, and then to the nearest 10th, it would be 13.6. Okay, so I would just say 13.6 as my final answer. All right, so that's the final answer, 13.6. So second trace 5 just wins. Like, please do that. All right. Let's see. So the model responses, like how, because I think the algebra, like, I mean, it's nice to see, but it's like just kind of exhausting, and it's like getting late. I'd rather people, get rest than watch me do algebra for another, long time. So I'm just gonna, let's see here, look at this craziness. Let me check how it looks in the stream. Okay, so this. All right, otherwise, what you have to do how they do. Oh, they wrote H instead of Y. I use Y. Is when they get to this step here. So see over here, H equals this, H equals this. Then they set them equal to each other. And they subtract this thing on both sides. And now you have like x tangent 52.8 minus x tangent 34.9. And then you could factor out an x and then divide both sides. They wrote this in the calculator and got this crazy decimal. And divide both sides by that. And you get x equals 9.00, blah, blah, blah. And then, but you have to solve for the height. So they plugged x equals back in, cross multiplied, added 1.7 and got 13.6. So this is also valid. All right. This is like more like, ooh, you know the algebra. But like, if they don't say do it algebraically, like why do the crazy algebra? All righty. All right. Well, people, this, what's it called? Is going to, wrap up the Regents. Oh yeah, proofs. I mean, if you scroll back to like the triangle proofs, like for sure, like it's there. Plus all my old Regents. But I just want to wish everybody good luck tomorrow at 1:15. All right, just deep breaths. Like you're gonna be okay. No matter how you do, you're still gonna be you when the test is over. You'll learn something. Anytime you go through like a big competition or a big test, you'll be like, oh, I should have studied this. I should have studied that. November, I shouldn't have goofed around as much. Like, I don't know. Like something. You'll find something you could do better next year. But, yeah, that's what I'm going to say. So good luck, people. And wish you all the best. If you didn't subscribe, consider subscribing. But I'm going to say good night.